Hello, everyone, and thank you for joining our live session today. My name is Larissa. I'm an event planner at Reactor, joining you from Brazil. Before we start, I have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional and on topic. The session is being recorded and will be available to view on demand here on the Reactor YouTube channel. Keep an eye on the chat, we'll be dropping helpful links and checking for questions. I will now turn it over to our speaker for today. So thank you everyone and let's welcome Raki here on stage.
Hi everybody, Raki Raman, nice to meet you. Larissa, if you could go ahead and swap over to my screen, share. Thank you. Awesome. Let me go ahead and provide a quick introduction of what I do. I obviously work at Microsoft. I'm on the SQL Server team, which you might be aware is a very popular database engine. So in particular, within the SQL Server team, I'm part of a team called the Telemetry and Intelligence. And so what that means is my team, we gather telemetry, real-time telemetry from every single SQL Server engine that's running across the world, whether it's in Azure, whether it's running in another cloud provider, whether it's running on your laptop, your on-prem data center. So we basically have petabytes of telemetry being generated every day. And my team, we are one of the largest customers of Fabric within Microsoft. And I'll walk you through is essentially how we have gone ahead and built an AI native data platform, which is the topic for today. And yeah, we're going to talk about some architecture. We're going to talk about some real life tools and techniques that you can pick up. I'm going to leave you with some code. We're going to have a lot of fun, basically. Larissa, is there anything that you want to go through with regards to these, or should I just kind of skip past these slides?
Okay. No worries, you can move on. Our moderators are helping us in the chat with the information. Thank you.
Awesome. All right. Well, thank you, moderators, for all being here. Really appreciate everything you do. So let's talk about the agenda for today in the next, I guess, 57 minutes that we have each other. I mentioned what my team does at a high level, but I'll walk you through basically like what our architecture is, what kind of scale we're looking at, how many number of Spark jobs that we have, things like that, essentially, just to get you to appreciate, essentially what kind of operations we're running. And from there, I've been a customer of Fabric for about 3 years now. We've been using it since basically before Fabric was even in the market. And when you use a tool a lot, you end up basically building opinions on what is the right tool for the right job. And so I'm going to be leaving you with tips that are 100% my personal opinion based on using Fabric. Sometimes they might completely align with what you might see in the Microsoft docs. Sometimes you might find that it is a little bit more opinionated, but I'll leave you with some tips on what I think are the right tools to use for the right type of job and the right type of workloads in Fabric. We're going to talk about production-ready testing and CI/CD when it comes to writing AI native code. So, for example, one of the things that you might have seen, if you're on the internet, is like AI slop, quote unquote, right? It's a bit of a, I would say, like, it's a bit of an interesting term because on the one hand, I think all of us that are here agree that LLMs are quite delightful. Ever since OpenAI came out with ChatGPT in 2023 or whatnot, I think it is safe to say that it has basically gone ahead and turned our world upside down. But at the same time, I think we have also felt that when the LLM goes ahead and it says something that is not accurate, or it goes ahead and makes things up, we as human beings, we tend to feel a little bit, I would say, betrayed, right? Because you feel like, oh, it's sloppy, it's just trying to fool me. So essentially, when you're trying to do AI native data engineering, what I like to say is the only job of a data engineer, like, you have one job, right? You need to take data, and then you need to present trustworthy data in front of your business, in front of your leadership. And there's no room for slop, right? It has to be accurate, it has to be trustworthy. So what does it mean to be an AI native data engineer when you're trying to use tools that can hallucinate? How do you kind of go ahead and test the output out of these tools so that when you are accelerating your work and you're making things faster, you can go ahead and do so in a trustworthy manner? So we're going to basically go ahead and decipher the statement that I just made with rigor, and then I'm going to be showing you a demo of exactly how we go ahead and use this in production. I'm going to show you our development environment, And then I'm going to leave you with something called a VSCode Devcontainer and the idea of an LLM sandbox and why basically allowing the LLM to have a fearless playground where it's able to write code, read data, and is able to do things without causing any damage is a very powerful concept. All right. So let's go ahead and talk about, just from an architecture perspective, I said we would use the right tool for the right job. So the way I think about it, what you see on the left-hand side is basically like, this is a vendor agnostic modern data architecture. What that means is there's no products, there's no kind of logos and things like that. It's basically just things that you need in order to build a data platform in today's day and age, right? So first of all, you need to go ahead and orchestrate data. You need to have data that is being ingested in a stream and a batch. In Fabric, we use event streams, which is actually the Event Hub Kafka API, which I have on the screen here. We do essentially almost 100% of our transformations using Apache Spark, which has obviously the data frame and the SQL APIs. You can do machine learning, you can do distributed compute, so that's kind of where the transformation fits in. Data exploration can be done using the Fabric SQL endpoint. You can also use Spark, and you can use the Event House, which offers the KQL engine. And then finally, as we're all aware, we use the semantic model, which is the analysis services engine, which is what our leadership are going to be interacting with in order to have millisecond level responses. And then obviously we use OneLake as the central source of truth, and then OneLake catalog is where all the metadata is showing up. So just to give you a quick kind of a sense of our walkthrough, so we have, just like everybody else, we have the whole bronze, silver, gold architecture, which I'll kind of quickly go into. I won't go into too much detail because that's not the topic of discussion for today. But what I'm showing you in the previous slide is basically our silver zone, which contains about 5 petabytes of data. I think it's more now, but when I last took the screenshot a few months ago, 6 months ago, it was about 5 petabytes. So we essentially have a lot of data that is coming in. We are storing it all in OneLake. We have tables that can range into the petabytes range, and we're trying to do AI native data engineering. I'm on a team of about 4 engineers, so it's a fairly small team, and we have to basically manage an ever-growing volume of data. So basically, the only way we can scale without scaling our headcount is to be able to use AI, and that's kind of the problem statement that I personally live with on a day-to-day basis with my job. So from an architecture perspective, again, not going to focus too much, but essentially, we have every single SQL Server customer in the world. I think we have over 3 million plus customers, if not more, that are running SQL Server, and my team is ingesting a couple hundred terabytes, I think it's more now, of data in real time into OneLake, where we're storing it as Delta Lake tables. With regards to bronze, silver, and gold, we have very specific, I guess, like mindset when it comes to like delineating what is bronze, what is silver, and what is gold. And the way we aligned our explanations of these things is anything that doesn't have a schema. So basically, you're taking a gzip. We're going to look at that in very much detail with the AI today with the Copilot, is when you're storing data that is coming in from a source system and you have no idea what the schema of the data is, like, is it a JSON? Is it an XML? Like, you don't know. It's just a string, essentially. We like to call that bronze. And the idea is the data is not going to have any compression because it's basically stored inside of a string. But at the same time, when your source system is giving you more information, you don't need to make any code changes because technically you can store anything inside of a string in Parquet. And so the idea is we can do what is called schema on read. And that allows us to infer schema when we're going to be reading the data. And if we ever got the schema wrong, we can basically go ahead and come and reread the data and backfill it and so on. So in short, our bronze zone, which is about 6 petabytes, we like to call it like schema on read. And then anything that is basically stored inside of schematized tables as columns and rows, where there are like very specific data types like integers, booleans, timestamps, and things like that, we like to call it silver. And these are essentially schematized tables. The idea is you want to store as much data as possible inside of your silver zone, and you want to go ahead and store it for as long as possible. The reason being is because when you store your data inside of these schematized tables, you're going to get all the benefits of Delta Lake, which is run on Parquet. So you get run-log encoding, you're going to get columnar compression. Like you get all of the benefits of storing data in a columnar format when you have gone ahead and basically denormalized the data as much as possible and stored it as rows and columns. So from then, we basically use a tool called dbt, which is data build tool. I'm going to have a few slides talking about why dbt is one of the best things that you can do with regards to doing AI native data engineering. And the idea is, obviously we have all this data, right? So my job as a data engineer is to basically take all of this high velocity, huge data, which dealing with big data is like a job in itself, and essentially making it available in these silver zones such that my leadership, my business, my product managers, my data analysts, like anybody who has more context about the business than I do, they are able to go ahead and access this data and query it in a manner which is going to be performant, which is going to be fast, which is going to have, no lossy rows and columns. Like there's no data loss. The SLAs are, less than 5 minutes. Like essentially just maintaining a very robust data catalog of information. That is essentially like the hardest part of, I would say, my job, right? So there's basically two aspects to it, which we're going to focus on with AI today, which is how do you go ahead and take data that is coming in with all sorts of weird schemas, and then how do you performantly persist it inside of the schematized zone? And then when you've gone ahead and solved that problem, what you want to do is you want to take your business users, the people who have more context, and you want to arm them with a tool which is very simple, right? Because obviously, if you're using Spark, you have a background in big data, you have you might know Python, you might know Scala, like you have gone through some sort of formal training in order to do what you do, right? But a lot of people who are part of the business, you don't want to make expectations. Like you don't want to assume that they have a certain set of skill sets in order to derive value from your data. And what you're going to find is this DBT tool is absolutely incredible with a very, I would say, like a very simple surface area. All you need to do is learn SQL, and then you just need to do some quick training, maybe like a couple of days of training, and then you're able to basically become very good at DBT. And that allows you to do self-serve data analysis. So when I realized that, this is when we basically said, okay, we're going to do all of our silver to gold using DBT. And what you're going to find is the way DBT is progressing as a tool nowadays, it is highly aligned to what LLMs are able to do, because LLMs have been trained on data that comes from DBT. So in short, data and software engineers, we like to use Spark, we like to use coding languages. And then the moment the data is stored in a format which is highly compressed and highly performant, you want to go ahead and make it accessible to your business users so they're able to build, delightful star schemas that answers business questions as fast as possible. Okay, cool. So let's spend, how much time? We have 45 minutes. So let's spend maybe like 5 to 10 minutes just talking about, if you're not familiar what data build tool is, what exactly is it? Like what problem does it solve, right? Like why are we using it? So in short, let me just take a step back. If anybody here is a data engineer, and you've worked, let's say you join a new team, what you're going to find is there's all these very, 10,000 lines long SQL statements that may be inside of a stored procedure or a file which is not tested, and you kind of just see it and you're like, I have no idea how to test this. I have no idea what these joins mean. Nothing is documented. I literally have no idea what I'm doing here, right? This is usually the reality in the data engineering industry, right? So you have no idea what the previous person did. If you do somehow know because they gave you a knowledge transfer, there's no tests, and this SQL doesn't run locally. And when you try to run 10,000 lines long SQL, usually it ends up costing like $5,000 and maybe like 6 hours to run inside of a cloud data warehouse or an on-prem data warehouse, right? You're not going to have a lineage diagram. So for example, nobody has one SQL, right? You have one table, you're going to have another table. So this kind of view that you're seeing on my screen, unless somebody has gone ahead and, maintained a directed acyclic graph, which is what this diagram is, you're not going to have a lineage diagram either, right? You just need to read the SQL files and see the joins, and then off you go. Now you might be thinking, hey, AI is awesome. So I'm just going to go ahead and take this folder full of SQL and just give it to Claude or Copilot and tell it to figure out. Well, guess what? These tools nowadays, they have a context window. You cannot just take, Copilot and point it to billions of SQL files and tell it to grok it. It's going to run out of context and you're going to run out of money, right? So you cannot just throw AI at absolutely every problem in the world. But the problem in the data industry, which is SQL is complex and business questions are complex, you cannot just say, hey, give me less SQL, right? Business users have to ask questions, and therefore we need to have very complex SQL. So that's the reality. And, I have a little emoji here, which is somebody who would be seeing this and puking. That's usually the kind of reaction that most data engineers get. Next, data engineers have no idea why somebody took a SQL file and have 10,000 line long CTs, right? So you might have a standalone CT, which goes in and feeds into a main. You might have nested CT that feeds another CT. And the best ones is where you have recursive CTs, which basically call each other and not other over and over and over until the main CT returns, right? So data engineering can get very, very complex and get very, very exciting. Let me just put it that way. You don't know where to read it, right? As human beings, we can only grok so much. It's just like having a context window, right? We have attention spans, and usually what we like to do is look at a piece of thing, try to understand how the ins and out works, and try to build a mental model of how to do that. Can't do that with a 10,000 long CT. If you do figure out how to make a change, well, the next person who's going to come in and try to build on top of that, he or she has no idea either, right? Because there's no way to basically reuse parts of it. Testing is out the window. Like, how do you take a big old file which has 10,000 long line? How do you test it, right? How do you break it into smaller chunks? How do you version it? How do you make sure you're not making breaking changes to data that your CTO or your CVP might be depending on, right? So these are the problems that we as data engineers basically have. So thankfully, this is not like just data engineering, right? So this problem that we just talked about, which is you have a bunch of SQL files and you need to orchestrate it. This is relevant in other parts of the industry as well. If you're trying to do front-end development, right? Like previously, people would go ahead and have a file, and then they would have something called jQuery, which is you would just go ahead and run some inline queries, and then you would build a website like that, right? Container management, you might be using something called Yarn, where you have to go ahead and take all these containers and lift it up yourself rather than having an engine that does it. Infrastructure as code, you might be used to running like PowerShell or Bash scripts with AZ CLI or Fab CLI to deploy all your infrastructure. But at one point, what you're going to find is when you have 5,000 of these things to deploy, sometimes that large script that you have that takes like 5 hours to run isn't usually the best thing to do. Same thing with ETL orchestration, right? You could take a bunch of stored procedures and SQL files, and you could use something like Data Factory to orchestrate, first run this, then run these in parallel, and so on. But usually what ends up happening is when this blows up into a massive directed acyclic graph, it doesn't scale, right? So everything that we just talked about, this is imperative. What that means is I say, first do this, then do that, then do these things. This is where you're being imperative. You're trying to prescribe to the system, hey, I want you to start here and end here, right? Whereas when you're being declarative, you say, hey, no, I have this folder full of, let's say in Kubernetes, a YAML files, or I have a folder full of Terraform.tf files, or I have a folder full of .sql files. I have no idea where to start and end, but you figure it out, right? So that's being declarative. You just say, these are the things that I have. I don't know where to start and end, but I want you to go ahead and do the right thing, right? So essentially, a tool like dbt, what it basically allows you to do is just take a folder full of SQL. It could be like 50,000 different files, no problem. And then dbt is going to say, okay, so this is actually joining from this and this. So I should first load these two, and then I load this. And then I can do these in parallel, right? So basically, dbt works back from what you've asked it to do to figure out what is the first set of things that it can do that doesn't have a dependency, and then go on to the next, and then go on to the next, and so on, right? So all you do is you take your business logic, whatever your business user wants, go ahead and pop it into a little file. You make that file really small, you add some tests around it, and then you go to dbt and say, hey, please make this happen, right? You're being declarative. So these are the pillars of dbt. And obviously this has nothing to do with AI yet, but once you understand this foundation, you're going to find that the limitation of LLMs is the fact that these things have like low context windows. So when you can like take them and box them into a framework that they cannot like escape out from, what you're essentially able to do is you're essentially able to use these LLMs to do what you've asked it to do without dealing with slop, as you're going to find out, right? So you need a framework, you need some pillars, you need some discipline. And essentially a tool like dbt is already disciplined even before AI came into the picture. So when you take dbt and you adopt it into your data engineering platform, you're going to find that all of that discipline allows you to be AI native. So for example, one of the things that dbt, the tenets that dbt stands for is there's no DDL or DML. So, there's no insert into, alter table, create table with, Boolean. No, you just write your select star. And these database engines are very smart, right? Like they're usually very, very good. And so you go ahead and do this thing called create table as select. And then you tell this database engine, hey, I have this select statement. You go figure out what the data type is. They're going to do something called a schema inference. And then the database engine is going to say, okay, so this table needs to have an integer, Boolean, blah, 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 right? So you just focus on your business logic and then let DBT using something called an adapter go ahead and talk to the database engine, and then you let the database engine figure it out, right? So you don't, it's like one less thing to worry about. The other thing in DBT is called don't repeat yourself. So one of the things that you're going to find, obviously this is not going to be a lesson on DBT, but it allows you to like modularize code so that the only thing that you focus on is business logic. And that way you don't have to have like the same functions and CTs everywhere, right? You're basically able to reuse what you've built and then test it. And that allows you to, as someone pointed out in the chat, it allows you to build for scale. Model versioning is a huge thing in DBT. You can have version 1 of a model, and then if you have a breaking change, you have V2, and then you tell your users to use V2 and don't use V1. Like all of that is kind of figured out. And then finally, you can do data quality tests, right? Like I have a SQL file, fine. How do you know that I'm not like dropping all the rows the moment I check in a PR? Well, one of the things you can do in DBT is you can go ahead and run tests, right? You can say, hey, my primary key cannot be null. Revenue cannot be like minus, right? Things like that. Time cannot be like 900 years in the past, things like that, right? So in DBT, they have the concept of unit tests and integration tests as well. And you can run your custom tests and essentially allows you to basically have data quality as like a first-class pillar of DBT, okay? So that's DBT. And what they've done on top of that is they have built these things called DBT agent skills. In short, it's just a bunch of markdown files. You can go to your favorite web browser, search it up, and what you're going to find at the end of the day is these LLM agents, like let's say Cloud Opus or OpenAI GPT and so on and so forth. Obviously, because DBT has been around for 5 years, these LLMs have been pre-trained on all of the stuff that exists on the internet. It knows exactly what DBT is, right? And any LLM in 2026 knows exactly what DBT is. So when you go to an LLM and you're like, hey, I've got this DBT project, please go ahead and do blah, blah, blah. It already knows exactly what DBT is, so it knows how to do blah, blah, blah very, very, very well. Versus if you have your own bespoke, like platform framework that you build, I don't know, like RakiBT or something, you go to LLM and you're like, hey, I have this custom framework that I've coded up for my own team. It's called RakiBT. Well, the first thing the LLM has to do is it has to learn whatever you built, right? Because it's not like public knowledge on the internet. And then by the time it's done learning what you've built, you've already filled up your context window. And so the thing that you want this thing to do, it's not going to be able to do it as well, right? So this is where you want to kind of like align on things that are industry standards like DBT that everybody in the world recognizes. And then what DBT has done is they have built these like, skills that are very, I guess, like commonplace that allows these LLMs to be prescriptive. And then the idea is you take these skills, you give it to your LLM, you give it to your code base, or you give the LLM your code base, and it's able to do a lot of different things for you. It's able to do testing, debugging, natural language querying, so on and so forth, right? Migration into a new DBT framework, things like that, right? So in short, the value that I personally derive from DBT is the fact that it's got very good solid pillars, which LLM or no LLM, I would agree upon. And then the fact that there are these skills which they have built by working with customers across the world, which allows you to go ahead and use an LLM in a very kind of delightful manner, right? So with all of that context, I don't work for DBT, and it's just a tool. It's free. I don't pay for it. Just a very big fan. What the mindset that I have come to after using Fabric and Spark and DBT and all these other tools is the fact that I've got all this data that is coming in, and I want to use LLMs on a very small team, right? Usually, like one of the things you're going to learn about being in the industry is like when something is like very hard to do, like dealing with huge petabyte-sized data, Spark streaming, and machine learning and all this fancy stuff. You're usually not going to have the talent in the industry who wants to do the hard thing. Like I'll just be very, very kind of honest. When you're trying to tune a Spark job, you can only do that on the job. Why? Because when you're like trying to deal with big data, first of all, if you're just a normal human being with a like a student budget or whatever, you're not going to be able to work on big data. Why? Because your wallet is going to like evaporate, right? So you're not going to use your own money to bring up like massive Spark clusters, obviously. So in order for you to even get good at big data, first of all, somebody needs to hire you, and then they need to present you with a big data problem where they have the sufficient finances in order to fund big Spark clusters. And then you're going to go ahead and like build up the expertise that allows you to be like a Spark expert and deal with huge petabyte data sets and skew and all that stuff. So for example, in my personal career, I have been privileged to work for companies like Microsoft, where like we have huge data, and so therefore we need huge Spark clusters. And then as I've been working in this problem space, I've been able to like really learn doing Spark and doing Scala and doing all this kind of fancy stuff in a way which allowed me to become really, really good at it. But the problem is, if I want to hire like 5 more people like me, it's hard because like not everybody has big data, right? Like most people have like relatively small data. So I guess in short, what I'm trying to say is I want to minimize the amount of fancy Spark code that I write to go from bronze to silver, such that I don't need to maintain this code, right? One of the things that you might know about coding is the more code that you have, it's a liability. So you want to minimize the amount of like custom code that you have, but at the same time, I'm not going to say, go ahead and do like schema on read using DBT, like the right tool for the right job, right? Like the things that you're going to be able to do using a robust coding language like Scala or Python using DataFrame, where you can use like regular old software engineering APIs. DBT as a SQL first tool is not going to expose that to you, right? So you need to use the right tool for the right job. And we're going to show how I use AI today, like in production, on using a like bronze data, which is very weird looking. And we're going to go ahead and form a silver table, and how I box the LLM into writing the minimum amount of code required. I don't want the LLM to go and generate like 10,000 lines of Scala, right? Like who's going to maintain? I have no idea how it works, right? I don't want to maintain it. So one of the things that I'll leave you with today is how do I go ahead and build a data frame based API framework that is similar to the pillars that we saw on DBT, and how do I go ahead and use an LLM as an engineer on a very small team in order to solve very big problems which are very complex, right? This is one of the hardest problems, where you take schema on read and you turn it into schematized tables. One of the things that if you've used Spark for a while, DVD agent skills. If you just go on like Bing or Google and you search for it, you'll find it. But maybe I'll leave it at the end of the chat today. One of the things that you might find about Spark is one of the greatest things Spark has is called Spark streaming. And the reason it's delightful is because the moment data drops in Event Hub, instantly you can get it into bronze. The moment it drops in bronze, you can instantly get it into silver. So it's basically real-time data processing, right? And when you have a very high amount of data that similar to what my team has, I cannot afford to like spin up a Spark cluster, process the job, spin down the Spark cluster. Like it is to the point where we always need to keep the Spark cluster running, because the 5 minutes that it takes to start it, and then the 15 minutes takes to run it, and then the 5 minutes takes to stop it, I've lost 10 minutes. So it is much simpler to actually just keep the Spark cluster running all the time and essentially just do stream processing such that the data is made available to Silver, right? At that point, when the data is made available in Silver, within Fabric, what you're going to find is there are 2 SQL first engines that you're going to have access to, right? So in short, when you're in this bronze to silver, my personal opinion is you should be doing stream processing in a manner which is called incremental processing. What that means is you never want to read the same set of bytes again, right? If you have a table, you've already read 10,000 rows, you want to start from 10,001, and then you want to go forward, right? You don't want to go back and reread the data, because what you're going to find is when you're like reading this raw data over and over, it gets very, very expensive, especially if you're trying to do like 1 year's worth of back processing, right? So in short, this is called incremental processing. And you want to go ahead and do incremental processing into a schematized table, which has very, very, very good compression, right? Like you want to go ahead and you want to make sure you have primitive data types. You want to explode all the nested data types out. You want to basically have the tiniest amount of Parquet files representing the largest volume of data, which is going to allow you to have very like minimize bills on OneLake, right? Because you're basically not paying for bytes. You're letting Parquet do what it's best at, which is columnar compression. Now, from that point onward, you want to go ahead and enable your business users to be AI native, such that people who don't understand incremental processing and query performance optimizations and things like that, all they want to do is say, hey, I have a new business use case, and I have a catalog full of silver tables. And Mr. LLM, can you please study this data and then use a tool like dbt to answer the questions that I have for you? And then go ahead and write up some unit tests on, referential integrity, data validation, and things like that. Like, just go ahead and these are my requirements, and then just go ahead and write the SQL and test it, and just open a PR, right? Essentially, that's what you want to do. So in that particular case, what you're going to find is Fabric offers 2 SQL first engine, right? And what you're going to find with SQL first transformation is performance is king. Personally, I've come to the opinion when dealing with LLMs is that you want to do what is called full processing when you have thousands and thousands and thousands of lines of SQL, because inevitably the LLM is going to get to the point where it's going to make breaking changes, or your business is going to change, right? Like today, let's say revenue has to be less than $100. Tomorrow it might be more than that, right? Things like that. So you're always going to have ever evolving business requirements. And what you want to do is you want to pick a database engine which allows you to process both full and incrementally fast, right? And in Fabric, there you've got the lakehouse and you got the warehouse. Again, I'm not going to spend too much time. I just left some notes here. My personal, advice is the warehouse has significantly less knobs to tune, and so it is a lot easier. It is less infrastructure for you to deal with. There's just less things that you have to do, right? As a SQL first engine, and if you can, you should go ahead and use it. My team, we use the lakehouse today, and the reason being is because the business that I'm in, it is I need the knobs, right? I need to go ahead and tune the shuffle partitions. I need to go ahead and tune the size of the Parquet row group. Spark does give you those knobs, and basically use the right tool for the right job, right? So in short, try to minimize the amount of custom code that you're going to have with notebooks and data frames and Python. You can, right? Absolutely you can, but keep in mind you are owning that code, and if you do not have test coverage and you're throwing LLMs at writing more code, at some point it's going to become sloppy. On the other hand, if you're using a tool like dbt, which forces you to write tests, which forces you to have unambiguous requirements, you can very safely go ahead and throw LLMs at the problem, and you're essentially able to minimize the amount of AI slop, right? So we have about 27 minutes left. We're going to go right into the demonstration. So the way my team, we basically use Fabric is I'm a big believer of doing local development. And so what I mean by that is, I have Visual Studio Code. I've got this powerful laptop that I paid good money for. I want to go ahead and use my local environment, right, in order to do as much data processing as I can on a representative subset of data that represents my production, right? And then obviously, I'm not saying go ahead and do big data analysis on your little computer, right? It's going to go ahead and, your CPU is going to be on fire. It's going to overheat. It's going to be awkward. But what you want to do is you want to go ahead and do as much local development as possible, which allows you to use all of the AI tools that are in the industry. I'm just going to be very blunt. We use Fabric, right? Fabric is a very modern and up-and-coming data engineering platform, right? I don't think anybody can argue that Fabric's not going to compete with Anthropic, who are like LLM native. They're the fathers of Claude, and they have all of this delightful, the right tool for the right job, right? So personally, I'm of the opinion that I want to use the data engineering platform for what it's good at. When it does have AI, operations agent and other things, which allows me to do lightweight analysis using AI, absolutely I will. But when it comes to doing data engineering, when it comes to being productive as a small team that has a big mandate, I want to use the best tool that is in the industry. So for example, if I want to go ahead and use Cloud CLI, I'll go ahead and do that. I'm a big fan of Copilot CLI, so I'll go ahead and do that, right? If I want to have the flexibility of having 10 different Windows terminals that are open with 10 different Copilot sessions running 10 different branches, I want to have the flexibility of doing that, right? As an example, you cannot take your Fabric workspace and tie it to 10 different Git branches. It's physically impossible. There's a one-to-one relationship. So if I want to do 10 different tasks at once, I can't do that on Fabric. So what can I do? I can go ahead and have 10 different Git work trees in Visual Studio Code, and Copilot CLI will be more than delighted to go ahead and do 10 things at once, right? I'm not limited by, I guess, like the platform's capabilities. I am limited by my imagination and the business requirements that I have in order to deliver, right? So in short, big fan of using local development tools. Now, one of the problems that you're going to face is, okay, so I've got my data in OneLake, right? How do you go ahead and like do analysis locally? So this is what I'm going to show you inside of the demonstration in the next 20 minutes or so. So one of the things that we do is we built something called the Visual Studio Code Dev Container. Nothing to do with Fabric or anything. It's basically just taking a set of requirements, and you can go ahead and take Spark, you can go ahead and take Docker, and you can go ahead and just containerize it. And what we basically do is, if you're familiar with the OneLake Explorer in Windows, it allows you to take your Windows computer and then like browse OneLake on your computer as if it's like running in Fabric, right? That's called the OneLake Explorer. What it's actually doing is, Windows has the ability to talk to the ADLS Gen 2 APIs, the blob APIs. And the OneLake team basically built a beautiful looking Visual Explorer that basically makes those API calls, and it assumes as if like it's running on your local file system, right? So on the Linux front, which is where this dev container comes in, there's a thing called BlobFuse. Again, it's on GitHub. You can Google it. What allows you to do is take any Linux computer, in this case, it's a VS Code Dev Container, and I can trick it into thinking OneLake is a local hard drive. And I'm going to show you a demo of that, right? So what I can do is I can take our production OneLake, which might be like 100 petabytes, and I can mount it on my local file system. Now, that doesn't mean I'm actually like processing 100 petabytes on my local file system. All it means is I am allowing my computer to traverse a 100 petabyte hard drive. If I need to read one Parquet file, I can do so, as if my local hard drive had 100 petabytes on it, right? Essentially, that's what BlobFuse does. It takes your local file system and it abstracts it with OneLake, right? If you want to read 100 petabytes, you're going to have a hard time. But if you only want to read, let's say, one Delta Lake partition with a Hive partition or a cluster by, you can only read the 5 Parquet files, and that's not a problem. Like any computer can read 5 Parquet files, right? So we go ahead and we run Spark locally, thanks to Spark being open source. You can go ahead and just download Spark off the internet. You can run it in a container. I'm going to be leaving with Git repos where I basically have a pre-built dev container that you can try using Copilot yourself. And then we also run the warehouse as a SQL Server on Linux, a mock, essentially. It's the exact same T-SQL API, so you can just go ahead and use T-SQL on a container, and it's as if you're using the warehouse in Fabric. So then, we go ahead and do some vibe coding. I'm going to show you some demo of that. And then we use dbt in order to go ahead and use these engines. So essentially the idea is, let's say my boss comes in and 10 other product managers comes in, says, Raki, I need all of these on my desk by tomorrow. I say, all right. I go ahead and spin up, let's say, 5 different Copilot CLIs. I'm going to go ahead and plan out exactly what I want Copilot to do. I'm going to take those 5 tasks, spin up 5 Git branches, and then I'm going to have 5 different AI agents, which is basically going to go ahead and use 5 different dev containers on my computer. So for example, just to show you I'm not kidding, I actually have 5 different dev boxes. I'm going to RDP in. I'm going to have Copilot in each one of them. And then I'm going to go ahead and basically give it the task, and it's going to go ahead and parallelize. The code is going to be written. Copilot is going to use dbt locally with Spark, which is going to be running on top of OneLake. It's going to go ahead and open a pull request. We're going to go to Azure DevOps, which is what we use in order to do CI/CD. You can use GitHub Action. It's the same thing. You can run Docker on these agents. It's going to go ahead and test exactly the new code that was generated by the AI on top of production data that is mounted. When the tests pass, I'm going to approve the PR. It is then going to merge into main. We're going to use a tool called Fabric CI/CD to deploy it into Fabric. And then what you're going to find is, because dbt works in Fabric just like it did locally, the exact same code is going to go ahead and derive business value. This is how basically you can do AI native data engineering in a nutshell. And let's look at a demo of that. So before we go in, I want to just have a little fun. There is one of the things that if you follow the people in the industry that are like AI enthusiasts and influencers and stuff like that, like Andrew from Anthropic, you might hear the term like loop engineering, right? So why am I showing you Ralph Wiggum? Ralph Wiggum is a child in the Simpsons TV show, and the idea is that Ralph, just like LLMs, is not a very bright kid, right? He's a good kid. He's a very sincere kid. He's very delightful. He's very nice. You tell him to do something, bring you a glass of water, he's going to do it. He's very polite, right? But he's not very sharp, right? So what do you want to do with Ralph, right? If you need Ralph to cook you like a 5-star Michelin chef meal, you need to break it down for Ralph in a way where he's going to not get confused. Don't just tell like Ralph, hey Ralph, make a 5-star steak, which is going to win, the Michelin star, and make no mistakes. Like he's going to end up, burning the steak, right? Rather, what you want to do is like, all right, Ralph, you want to go and buy the Wagyu. It's a better cut of meat, and you want to buy this seasoning, and you want to do medium. Like you want to go ahead and break down what your end result is in a manner where you first need to know how to cook a steak, right? Don't just like assume Ralph knows how to cook a delicious steak, right? First, you should go and research how to build a steak. Let me see how far I can get with this kind of steak analogy. And then when you know what a good steak looks like, then you give your requirements to Ralph, put him in a loop, and you say, Ralph, until the steak is cooked exactly to the precise temperature with this thermometer that I've asked you for, do not stop. This is called a Ralph loop. You want to go ahead and take a problem space, and you want to go ahead and break it down in a way where Ralph Wiggum or an LLM can never get confused. When the steak has been cooked to medium rare with 200 degrees Fahrenheit, you want to give the LLM a very concrete entry point. The moment you see 200 Fahrenheit, stop working immediately and open NPR, right? So you want to make it extremely cutthroat. And that is called a Ralph loop. And I am a huge fan of, you're going to see one of them like right now, huge fan of using this tool. So the idea is I want to go ahead and use Copilot, which is just giving me like, off-the-shelf LLM models off the internet. I want to use DBT and Visual Studio Code when the right tool fits the right job. In this case, I'm trying to cook steak. So sometimes I might use LLM to do research on what a delicious steak should look like. What are the right type of seasoning to put in, or how to do SCD type 2 in data engineering, right? Like all these problem spaces are the same. First, you as the data engineer have to become competent of what you're trying to do. Don't just go to LLM and say, hey, do SCD2, make no mistakes. Don't do that, right? First, use the LLM to learn what SCD2 is, how to cook a good steak, do it yourself, learn it, do some POCs, become good at it. And then when you yourself know what good looks like, then go ahead and scale it to 10 different AI agents where you go ahead and take all those requirements and parallelize it using something like Fleet, right? So, enough talk. I'm going to go ahead and open a Visual Studio Code. We're going to go ahead and look at a real example of a real job, and I'll show you how we use these tools in order to go ahead and solve a real life use case, okay? So let me orient you with regards to what you see on the screen. This is our code base. So, in this case, I have Spark Scala code. As I mentioned, we're using Scala, which is Spark's kind of native language. So I have all this, I like to call it fancy stuff, which is like fancy stream processing code. I've got that side of my code base that is doing bronze to silver over here. And by the way, this repo that you're seeing, it's like open source, so you're going to be able to like see everything that I'm sharing with you at the end of this session. So you can go ahead and play around yourself. So I've got all my fancy code here, and then I've got all my DBT specific code, which is more aligned to like my business users' use case, right? So let's talk about a problem space. So let's say today I am trying to do some bronze to silver analysis, right? So let's say some new data has been loaded into my bronze zone from some data vendor who has gone ahead and landed it, or maybe I need to land it using Data Factory or what have you. But essentially, I have this data and I have no idea what this data contains, right? I literally don't know what this is. So what I want to do is I want to use Copilot CLI in a Ralph loop in order to go ahead and do schematized tables on top of it, right? The data may be gzip compressed. It might be an XML. It might be in a foreign language. I don't know. The first thing I want to do is I want to use LLMs to go ahead and study what the data actually contains, right? Data exploratory analysis, right? So what I have here is I have a skill. There's just something that like I basically like threw together myself. I just called it bronze to silver Spark transformer generator, right? So the first thing I'm going to do is I'm going to invoke it, and then you're going to find how I am able to box the LLM into, like, even though we're going to be writing Spark code, I am able to box the LLM into these 4 pillars, which we agreed upon is the foundations that you want to have in order to build a data engineering code base, which is going to stand the test of time. Okay, so I'm going to go ahead and fire the skill. Let's just do that. These AI back and forth takes a little bit of time. So I'm just going to show you, like, what are the important parts of the like, if I'm trying to tell Ralph to cook a 5-star meal, I don't want it to go ahead and do a git commit, right? I don't, like, because sometimes it might write code that I don't agree upon. I have given it the instructions that I'm going to be the one that writes the commit. I'm going to be the one that pushes it. All you need to do is go ahead and write code and test it and keep it locally, right? So these are basically the kind of instructions that I have given to my AI agent. If this doesn't work for your company, go ahead and give it permissions to push, right? It's just some guardrails that you set for the AI, fine. Then I'm telling AI, look, your job is to go ahead and reuse as much code that exists in my code base as possible. Like, just put yourself in my shoes, right? You join my team. There is already like 500,000 lines of code that exists inside of this code base, right? Like, you're not building something from scratch. Like, this is a system, this is a working business, this is a SQL Server team. There is already code that is here that is running in production. Like, just to show you what I'm talking about, we have bronze, we have hundreds and hundreds and hundreds of lines of code, right? Like, all of this is already there, it's in production, all of this is working, right? What I want to do is I want the LLM, like, even though today I have a new data set, right? Somebody came in and said, Raki, you need to ingest this new data and get it done by tomorrow. I don't want the LLM to like take the entire wheel and reinvent it. It doesn't make any sense. Like, if I already have code in my code base, which does something that already, let's say, takes a XML and explodes it into rows and columns, I want my LLM to reuse those functions. I don't want it to like rewrite the same thing again, because then I'm just going to have like 5 different types of XML explosion. I don't want that. So I'm telling it, okay, you need to go ahead and flow code that flows through this specific set of interfaces. And I have given it explicit examples. So for example, I'm saying, hey, I have this piece of code. Let's say it's called Mirror Maker Silver type driver. You need to go ahead and write code that already looks like production code that I have, right? Now, what does that mean? What that means is you as a software engineer or a data engineer first need to go ahead and know what is good code even looking like. So I mean, I'm just giving as an example. In case of software engineering, there's this thing called solid, which is basically a way of writing code in a way where you don't repeat yourself. So you can do object-oriented programming where you can have a abstract base. This is not a software engineering class, by the way, but the point I'm trying to make is, if you have like 10 different drivers, which are going to be reusing the code with logging, well, you don't want to have the same code in like 10 different places. You want to have it in a base class. And then what you want to do is every single driver that can reuse that code, you want to extend it, right? This is just, OOP kind of 101. And so I am telling the LLM, hey, I already have a pattern in place in my production code base, which is like already working. First thing you need to do is use that as an example. Don't go off and inventing your own patterns, right? So once you go ahead and load the data, transform the data, reuse as much of the driver entry point as possible, you're going to write some unit tests. You're going to register the Spark job in a YAML file. And then you need to go ahead and like register the vacuum, because if you're creating like 10 different tables, we need to go ahead and vacuum and optimize it, right? So basically, these are the instructions that I've given it to LLM. Fine. Then what you want to do is you want to give it context, right? Like, Ralph needs to know where the closest shopping center is, so it can go ahead and go to your butcher store or wherever it needs to get the raw ingredients, right? So I'm giving it some core context. So again, comes down to you knowing what good code looks like, right? So one of the things, again, we like to follow solid OOP principles. So one of the things that I realized early on is when you're trying to do data engineering, what you want to do is you want to make your code as testable as possible. Don't just go ahead and spin up a net new notebook where you just do like a spark.read from a petabyte size table and then do some with column, regex transformation in line, and then do like a spark.write into table. I mean, you can do that in a single notebook, but what's going to happen? This transformation code that you've written is not going to be testable. Every time you want to go ahead and test your like notebook PR, what do you have to do? It's always going to read a petabyte, and then it's going to run a transformation, hit the bug, and then it's going to write buggy data into your table, right? You don't want that. Rather, what you want to do is you want to take the core part of your business logic, which is the data transformation. You want to have it in a function, which is called transform, which takes in a data frame and spits out a data frame, right? So you're basically putting this in a box. And then if you want to go ahead and test it on like 10 rows of data that mocks production, you can just have a little CSV file, which is basically a representative size of your data. You can go ahead and fire that 5-line CSV file on this transformation, write the data into some dummy table locally, and then see whether or not the data that you were expecting got written, right? So essentially, in short, if you go ahead and follow some very basic, like this is not complex code, right? We just have an interface, which is taking in a data frame, spitting out a data frame. If you go ahead and architect your code base, which is following some basic principles, what you're going to be able to do is you're going to be able to have very complex business logic. Like, let me just, for example, like show one of these would look like. You're able to have very complex business logic, which can be tested very rapidly with an LLM without doing big data analysis at all, right? You can just like do test-driven development or basically like very confident engineering. So anyways, I'm not going to go into too much of the details because this is a topic in itself. But in short, you want to follow some best practices, whatever DBT gives you, right? If you're trying to use like Spark, Scala, or Python, because you don't have something like DBT, which kind of like forces you into a framework, it is your responsibility if you want to go ahead and do AI native data engineering to study, maybe buy a book on Solid or OOP, just learn some basic software engineering best practices on how to have line coverage, test coverage, and then build a code base for your team that allows you to use LLMs in a very confident manner, right? So in short, those are the kind of patterns that I'm going ahead and giving AI so that it doesn't go off, writing all sorts of weird code. Fine. Next, the LLM is going ahead. So there's 8 minutes. I'm going to go ahead and kind of just blast through the skill. Obviously, this is, we're not going to go ahead and go through everything, but I'll just show you a little demo of exactly what are the tooling that you need. And then I'll just kind of go ahead and, walk you through exactly what this raw fluid would do, which usually might take like, 30, 45 minutes, right? So first thing is I'm telling the LLM, okay, pause, ask the user to provide the raw table where you have the data, right? So this is where, as I mentioned, my team has mounted our production OneLake using BlobFuse locally, right? So I've gone ahead and like mounted that table locally, and I'll just to show it to you, like I've got this, I can basically query like our production data from OneLake inside of this like I have a Spark running locally, and I'm basically just going ahead and spinning up a Libby session, and it's going to go ahead and like query the data locally, right? So in this case, let's just say for the sake of our project today, we are going to be processing this like Synapse Spark diagnostic view, right? Which is basically like some telemetry that you get from like your Spark metrics, right? So let's just say for the sake of our project today, that's the data set that we want the LLM to process. So we go ahead and give that to the LLM. And what it's going to do is it's going to run local Spark SQL commands, just like we're running inside of the user interface. And that's going to go ahead and basically like find the data, like whatever the source of the data is, right? So you can see actually the LLM is going ahead and like finding the right place to put this code, which in this case happens to be Spark Diagnostic Silver Loader. And because I have given it those guardrails, because I've given Ralph Wiggum the guardrails and the interfaces, which I have in my team's code base, it has gone ahead and found Spark Diagnostic Silver Loader. How did it do that? It did it because I told it to go ahead and let me show you. So if I Spark Diagnostic Silver Loader, because I have given every single like piece of our code the interfaces, which is the data reader, the data loader, and the data transformer. And these LLMs, all it's just doing is just like going to your local file system and literally just like, actually it's just doing like Control F. Like just like I'm doing Control F here for star.scala, the LLM is doing the same thing, right? And so when you've given it those guardrails, it allows it to not fill up the context window, do some string matching, and then basically find out the right place to put the job, right? So in short, we're going ahead and giving the LLM the right tooling. So I'm running a query with the local UI here. You can run a Spark command using like spark.sql using the Spark shell. And whatever I am seeing on my screen right now, which is actually just a bunch of gibberish, the LLM is going to see it, right? That this is the source of my data. Like, I cannot control it. The source system is giving me data in gibberish. How can I go ahead? Like, there's like two options, right? When you're a data engineer and you see gibberish on your screen, you either need to go ahead and guess what you think the data should be schematized into, or you can go ahead and use LLM to do it, right? So in this case, what I'm telling the LLM is, hey, by the way, the type of data I get on this team, either it's a JSON, either it's an XML, either it's base64 encoded, or is gzip compressed, or you get the point, right? You give the LLM the possibilities of what your data source providers would be giving you, so that instead of you going in and trying to examine this data, you let the LLM do it, right? Because your time is more valuable than the LLM. So anyways, in short, the LLM is going to go ahead, and if we had more time, you would find that it's able to figure out this is base64 encoded. It is going to go ahead and write the code. It's going to go ahead and find exactly the right file to put this code. It is going to go ahead and ensure that it's applying the best practices, column partition, clustering, you name it, everything that you would do. It would go ahead and write the code. It would follow a particular pattern. It would go ahead and write unit tests. You have to also tell it what the test structure is. So you can go ahead and give it some tips like that. And then it'll go ahead and write the unit test. And honestly, after I fire the skill, I'm just going to go off and work on something else. And within 40 minutes, I'm going to come back and there's going to be a folder full of diffs. And the LLM would have 95% done exactly what I wanted to do. Sometimes if it doesn't meet my requirements, I might change the code myself or go to the LLM and say, hey, this is not exactly how I expected. You need to change it. It's going to do that. And what that allows me to do is give Ralph Wiggum the ability to cook the steak that I want, the way I want it to, and then I can go ahead and cook a chicken breast in another session, right? So the point I'm trying to make is when you go ahead, if you want to be an AI native data engineer, first you need to know these like really good frameworks on how do you box the AI into a particular interface that scales. If you're able to use DBT as much as you can, go ahead and use it. If you need to use Scala and Python, try to have robust test coverage. In case of my team, we do local development. We have 3 minutes. So one of the things that we do, like the environment that you were seeing on my screen earlier, it is a Visual Studio Code dev container. There's nothing fancy about it. All you do is you say, hey, I want a Linux container. I want Scala and Python. And then I want to download Apache Spark and Livy off the internet. And I can go ahead and like install that in a container, which means, every time you're spinning up a new dev session, right? Every time you're spinning up a new task, you don't want to go ahead and, download Spark off the internet. Rather, what you want to do is you want to build this dev container once, pay for it, let's say 30 minutes, store it inside of a container registry. And then when you're working on a task, you want to go ahead and invoke the skill that I showed you, instantly go over to another development environment, let's say Racky Windows 5. And then I want to do the same thing on another branch, which allows me to parallelize with a small data engineering team and having AI agents that are native to my workflow, writing code the way I want it to. So the DBT, in this case, we're going to be also running DBT locally just to test first. So I can run it either on a SQL Server on Linux container, which runs on Docker, which is basically the same thing as the warehouse, or I could use Spark to run DBT, right? Depending on what kind of dialect you need and performance you need and things like that, you can use DBT on either of these. So for example, for DBT with Fabric, there are 2 adapters, the Fabric Lakehouse, which is the one that I personally use a lot. And then there's also the DBT Warehouse adapter. So you can use either. It works the same way. You can go ahead and do that in a containerized manner. And then when the task is done and you've opened up a branch, you want to go ahead and take that branch, open up a pull request, run through the dev container once again, run through your unit test, run through your DBT test, right? And then once the tests run green, you want to go ahead and merge the pull request into main. You want to use a tool like Fabric CI/CD, which is going to take that new code, which came from that branch, deploy it into Fabric. And then in Fabric, you want to go ahead and schedule your Spark streaming code, schedule your DBT code. And then, whether you want to use the Lakehouse, whether you use the warehouse, you're able to basically have that data flowing, right? So it's basically a factory. You have data coming in. You're using AI to go ahead and do as much data engineering as possible. You are testing the code. You're testing it with real data from production. and then you're pushing it into production, and then you're able to basically have more and more business value being generated on Fabric, and you're able to basically have a really good handle on this code. Okay, so we are on time. The code that I was showing you on the screen, you will find it in GitHub. I think one of the moderators can put it in the YouTube as well. And yeah, feel free to connect me with me on LinkedIn, or let me know if you have any questions. Yeah, that's pretty much it. I guess I will stop speaking now and let the moderators wrap up.
Oh, sorry, Rocky. Wrong click. The moderators have not sent any questions to be answered live, so I believe they did really well
Awesome.
with replying to our audience. So if you would wrap up, we're great. Thank you.
Okay. All right. I'll take a look at the YouTube questions and answer. But yeah, thank you for everybody for joining. Have a good rest of your day. Take care. Bye.
Thank you. Thank you, everyone, for joining. Thanks to our speaker and to our moderators. We always look to improve our sessions and your experience. So if you have any feedback for us, we would love to hear what you have to say. You can find the link to our survey on the screen or in the chat. And we'll on the next one.